All right. So we're going to look at actually properly getting these equations down. We had this table of points. We graphed them and we kind of worked with them that way. Now we're going to figure out how to get these actually to be equations that aren't awful. So what we're doing is we're going to start by looking at our supply. That was looking at these two columns together. So to write our equation for that supply line that we drew yesterday, we like to usually write our equations like that: y equals mx plus b, where we have m is our slope and b is our intercept. Yes, dear. You gotta wait for the 10 minutes. So 58. It's the first time we can go. So what we're looking at is we're looking at how the x's change. Remember, these guys were our x's, and how our y's change, and these were our y's. Because to find our slope, that's when we remember our rise over run. That's usually how we remember it. Rise over run. Rise rhymes with y's. So it's the change in y over the change in x. So we want to know, how much did our y's change here? What did we add? Between 35 and 130. Not 5. 95. I couldn't hear you. I'm old. You must be louder. All I heard was 5. How about for our x's? 1. That one I heard. So we're looking for the change in y's, which we had our 95 over 1. 95 over 1, it's the same thing as 95. So at this point, what we know is for our supply line, we have our slope of 95 times whatever that x is plus something. I got too many variables still here. I'm going to switch this back to be a y. I still got too many variables here. We have a couple of options when trying to fill this in. Since we know our slope, you can absolutely work backwards to find what happens at 0, because x is 0 is by definition our y-intercept. That's an absolutely valid strategy. I'm going to have us practice something different. Because another option is to take one of our points, like, say 135. We know this is a point on this line, 135, $1.35, whatever, dolls, whatever, things. Well, this is an x and this is a y. Let's substitute them in. So if we know that we're going to have 35 when we get 95 times our x, which was 1. Somebody's playing like calliope music in whatever video is playing, and it's kind of creepy. I was going to say, it's like when you think those old-timey steam organs that they play at like old fairs. Like the little ballerina boxes, but like the ones that are for like fairs and are big, they're called a calliope. And it's a steam instrument, but it's like used in all kinds of creepy music. So if we substitute in our x and our y here, we can solve this around. We get 35 equals 95 times 1, which is 95. Plus b, and what is our b going to equal? What do we do to get b by itself? Minus the 95. Oh, and I definitely just realized this crossed into the other set of equations. I crossed the instruction, but that's okay. If we minus 95 from both sides, that's going to give us b all by itself. And that means our b is negative 60. So this equation all by itself, which all of this stuff is meant to be up here. I just generally was not paying attention to the words that I jumped. So our equation is going to be our y equals that slope we found of 95x plus our b, which was minus 60. This is our supply. This is the one we did with these two pieces of information. Okay, So we find our slope. We can use a point to find our y-intercept. Absolutely valid option. You can also find your slope, work backwards to find your intercept. Another valid option. I want you guys to go find the equation for demand. So we did the supply one together. Write the equation for demand because we're going to use these together. So take like 4 minutes and do the same kind of vibe, same kind of thing, using our x's and these y's. We're looking for our demand equation.
I was like, I knew someone else was there asking. I was just like, I remember who it was.
What did we get for our slope on our other line, our demand line? We should get negative 130. So looking at our same x's, but our different set of y's. This is our set that we're working with now for demand. It's this guy and this guy. So we'll have our slope of negative 130. What did we get for our y-intercept on this guy? 660. So the equation for our demand is that minus 130x plus our b plus that 660. And that matches up really good with our lines. If we look, we estimated right around 650, 660 for our y-intercept up there. What we're going to do next is we are going to try and solve and figure out that equilibrium point, that point where they cross, that solution. So we want to know the solution to the system between these two equations. So I've got my supply equation here and my demand equation here. And we want to know the equilibrium, also known as when supply equals demand. We want to know when they cross each other. What can I do to try and solve that system right there? Yeah, we're going to set them equal to each other. It's kind of like a substitution. I'm changing the view real quick just so I can have a little bit more space to write. So, just because I was going to run out and that was going to be a mess. Let me bridge this real quick just so we can use that space. So we know our supply equation is our 95x minus 60. And we know our demand equation is this one right here that you guys just wrote, that minus 130x plus 660. And what we can do is we're substituting these in place of these letters. S equals this, just like if we had a y equals, we'd substitute them in, set them equal to each other. What do we do to solve this? How do we go about solving this mess? Get the x's to one side. Which one do we want to move? Add, so the 130, it's already negative, so let's go ahead and add 130x. Just as a little trick to keep in your pocket, to keep yourself from having to deal with negatives as much as possible, if you always move the smaller one, you will have the least amount of negatives to deal with, xy's. So negative 130 is smaller than 95. So we move that guy. When we do that, what do we get when we add together our 95x and our 130x? The 225x minus 60 equals 660. Then what do we do? Add 60. So then we have 225x equals 720. And what do we do to figure out what x is? Yeah, divide it by 225 on both sides. What do we get as our answer? What's our x equal? 3.2. What did our x stand for again in this problem? Price. So this is what price? It's where supply and demand meet. It's $3 and about 20 cents. Is right about where supply and demand meet, which is right about here. That looks really close. I said probably close to 325 yesterday. Looks pretty close to right on. How would we figure out how many dolls each store is ordering at that point? How would we figure out the Y there? Plug it in to which equation? Does it matter? It should be exactly the same. It does not matter which one we pick. But to figure out the rest of our solution, we would pick one of the equations and plug it in. I mean, supply has generally less icky numbers because it's positive. But so we'd take our 95 and we'd substitute in that $3.20 minus 60. And we could do that to figure out what that value is. What is our Y value here? $244. That looks just about right. If we take this and we bring it over, it looks like it's just under this line. $244 looks right to me. So $244 set at the price $3.20, and the store should wind up selling all the ones they buy and not running out, like, and not having people be angry at them. So the writing of the equations is sometimes really tricky, just especially because it's been a minute and a half since we found slope and found our y-intercept. I didn't do anything. I was using emphasis. It didn't change anything. Grumpy computer. You are mine. Slow your roll, ma'am. Okay, so the writing of the equations, like up here, it's been a minute, and that tends to be a place where we get a little bit stuck. Luckily, we're going to do a little bit more practice with it. Oh, snap. What? We are going to be on page... That is the exact same person number as I had before. Not the next one. One after that. Page 49/50. It's got a teeny tiny 22 on the bottom left. Because page number is fun. So this is a kind of similar vibe. We've got the data for 4 cyclists. We've got Dan, who's got a table, because Dan apparently just took 2 pictures on his watch. Just making it so that bar goes away. We've got Maria, who made us a little graph. Ryan wrote us an equation. And Helen, who gave us a whole story here. And what we're asked to do is we're asked to try and figure out who's fastest, who's slowest, who's passing who. So we can use all of this data here to kind of compare them. Make sure we're reading these carefully. You've got a graph at the bottom of the page. There it is. There we go. So what you can do is you can kind of base things off of Maria's graph to get everybody on the same graph. She's given us kind of an idea on scale, maybe. We probably want to have some time. We want to have some distance. Make sure we're paying attention to who starts where, all that jazz. But it's based on these things. So I want you guys to look at these. These come in a few different style of data that they're giving us. And we're gonna try and look at these answers at the bottom. But this is what we're gonna work on for like the rest of today. So we're gonna work on, so I want you guys to take like 10, 15 minutes and see if we can get all 4 people graphed. And then start working on seeing if you can answer these questions. Okay? So you've got that graph there. See what you can do. And I'm happy to help, but I'm just going to pause the screen for a second because I'm going to put a few things on here. So look at you're looking at page 49, and you're going to try and graph everybody on that same graph at the bottom. And you can work with your neighbor, that's fine. And if you want different colors for the different people, I can grab you that. Just give me a second. Because I do not leave myself any space to write on this graph. There we go. I'm going to grab the color pencils on here. You want different colors for different people. You can absolutely do that. Does sometimes make things easier to read. So I'm gonna grab the color pencils out. So this is kind of how I'm starting my graph. And I'm just using the same scale that Maria used on her graph, just because that's going to make things a little bit easier. But that's all I'm doing, and I'll put Maria's on here, and we'll do everybody else's together. Yes, dear. Yeah. That's how I'm gonna start. So we're used to seeing MX with B, right? What pieces do we have here? The MX part. So that means our B is gonna be what?
Oh, 0.
There you go. There you go. Okay. That's why I kind of am obnoxious about asking questions all the time because I'm like, I know you know it. I know you know it. Whether or not you believe the traumatic brain injuries and other So the one I have up there is the one that she doesn't. But yes, we're gonna take this in books. We're gonna get all 4 of these blocks in directions. Okay, and we're trying to see what's happening between them. They all started doing this really random race from all over the place. They all trying to end at the same time. That's about where I got and stuff and number and stuff. I just counted the exact same issue. I just took the same scale. Just because, man, she already did the work. Might as well let her. You have to work for us. She picked our X, she picked our Y, she picked our scales for us. To be fair, we hopefully don't need to worry about knockouts in here. There should not be any kind of knocking out happening in this room. Bless you. 'Tis the season. I cannot wait till we can open up windows and let some of this German air out of the building. All right, I'm gonna do Dan's next, just because I feel like a lot of you guys have Dan's. I'm gonna do Dan in blue. And Dan is at 1 hour. He's at 70 minutes, so he's about here. And at 4 hours, he's at there-ish. There we go. So this, that should be about what Dan looks like. Oop. Yes, sir. No, it's kind of like these are how these people start at 0. Mine's the only place that started. So she's the one. Yes, it's a positive. Then I'm gonna do Ryan. Woohoo. Chunky. I made a mistake when I was graphing Maria. My Maria line's wrong. I did not account for the change in my scale. My Maria line was wrong. My Maria line should be down like that. Because Maria went up 20 in 1 hour. She was up she was up to 60 at 2 hours. She was up to 80 at 3 hours. So Maria's line should really be over here. I made a mistake. Maria's really like this. So we gotta watch out when there's a scale change. I made a mistake there. So there, Maria should really look like that. Maria's significantly less than Dan. Yeah. Yes. It's because I counted by 2s on the bottom. So I like skipped and then did one, then skipped and then did another. Whereas I counted by 20s on the left hand side instead of doing like a skip. So I changed my scale from hers a little bit, so I wasn't paying attention. So Maria's should really look like that. So on 1, you should have her at 40, and then at 2, you should have her at 60. So you did fine. Yeah. I just didn't account for the fact that I jumped here. I just went with the pattern of do 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 do, and I counted differently. Yeah, as long as you matched up with points on the table, you should be fine. I just kept going. I was like, oh yeah, up 1 over 1. Ah. But then I counted my Y's differently than I did my X's, so that made a problem. There we go. Because when I noticed when I started looking at Ryan's, because Ryan is going up 1. Or up 30 over 1, but my 1 is all the way over here. Up 30 over 1, up 30 over 1, up 30 over 1. So Ryan's going to be over here kind of like this. There we go. That's where Ryan should be. Something like that. And then our last one's Helen, and Helen's extra because she's the one that wrote us that whole story. So if we can get those 3 and not sit up like I did, then we are in okay shape because Helen started cycling at 15 kilometers. So that means she didn't start at 0. So she's kind of like these other people where they started, like Maria started at 20. Dan started at 40-ish. Helen started at 15. So she's starting down here and traveled, so changed 50 kilometers in 2 hours. So if she's starting at 15 and is going 50 kilometers, she's going to wind up at 65, which is going to be down here, really close to where Ryan and Maria are. So she started 15 away and is moving 50 kilometers in 2 hours. So at 2 hours, she's 50 kilometers further. At another 2 hours, she's another 50 further. So that would be just shy of 120. So somewhere over here. So she's kind of there. That's Helen. There's Helen. So let's take a look at these questions and see if we can figure out what's going on. Who is going the fastest? You can go with color up here, that's fine. We got dark blue, light blue, pink, and green. I say Dan and Ryan both appear like pretty darn steep, right? So for question number 1, I'd say just by looking at the picture, we're only going to get so much information. I think it looks kind of like Dan and Ryan are really close. When we get to the point where we're looking at equations, we'll be able to maybe figure out who is actually going fastest. Because we're looking for the person who changes the most, which means they would have the biggest what part of the equation? Slope. So the speed they're going is the amount of change they're doing. So it would be whoever has the highest slope. So who's going the slowest? Maria. Maria's slowest. Dan and Ryan are probably fastest, or at least closest. And Maria is slow. And that's okay. Everyone's allowed to bike at their own pace. But she's currently going the slowest. Do we think Ryan will pass Dan at any point? What do you think? Yeah. So if we did look at the table and found a rate of change for Dan, if you took your data up there, we find how much it's changing in the hours. So 1 hour to 4 hours, that has a change in 3. And our change in kilometers are 140 and our 70. 140 minus 70 is actually 75. So if she changes 75 kilometers in 3 hours, we know Dan is changing at a rate of 25. So we do see, if you start looking at the equations, that since they have different slopes, they will pass each other eventually, but it's going to be a minute. It would actually be like, to say I was not particularly great at graphing my lens, because it should be around hour 9 or 10 that they start getting real close to each other. But it's going to take a minute to get there. How about, does Helen, pink, pass Maria? Green. Where does Helen pass Maria? I was going to say at the 60 kilometer mark-ish, which is about what time? About 2 hours. So question number 2, or question number, part C, I guess. Question C. At about 2 hours. Helen passes Maria. H will pass M. But it really depends on our graph and how good we are at graphing stuff. Then we can really tell stuff. Because it really makes a difference if our graph is wiggly or not. What do you think about Helen and Dan? What's their changing rates like?
She'll pass Dan the picture. But she's moving well, no, she won't. They're moving at the same pace.
They're moving at the same pace because we know Dan was moving at a rate of 25 kilometers per hour. So his M was 25 per hour. And if you looked at Helen's, if she traveled 50 kilometers in 2 hours, 50 over 2, she is also moving at 25 kilometers per hour. So they have the same rate of change, the same slope. So they're going the same speed. So Dan and Helen are never going to meet on the road. But we can see a little bit clearer than with Helen's line and Ryan's line, how Dan and Ryan will eventually connect because Ryan is moving farther away from Helen. So then the last one on this page is asking us to write equations. Straight up equations are y equals for each of these guys. So Ryan made it easy for us because he actually gave us the equation. We like that. Ryan's my brother's name, so we like Ryan. Ryan gave us his y equals 30x. What's up? How about for Dan? How would we write an equation for Dan? Which is actually my dad's name. Like, why do we have so much family member in here? We know Dan is changing at 35, or the 25. I'm just going to do an arrow so we don't have double equal sign situation here. So if Dan is moving at a rate of 25 kilometers per hour, we put this as 25x plus, where does Dan start? What's his time when the race starts? He's at 40 kilometers. His first information he gave us at time 1, but he started the race, he got going, he was really excited, he went, oh shoot, I forgot to start my watch. Dang it. So at the 1 hour mark is when you finally remember to hit start on the watch exercise. He forgot. So he actually started at 40 kilometers. He got a ways through and forgot to start his watch. Entirely, yes, because we have to work backwards on our table. Yep. So, because he should actually be at 45. Yes, thank you. Because his table was our 1 and 70 and 4, 175. And then he changed 25 for every 1. So it was 75 for the 3. So if we go back and fill it in, it goes down 25, which puts him at 45 here. So you can absolutely fill it in that way to get us down to that 0. How about for Maria? What is the equation for Maria's line? First person in here I don't have family with their name. How much was Maria's changing? 20. She went up 20 every hour over. She went up 20 over 1, up 20 over 1. So her slope was 20x plus, where did she start? At 20. And then our last one up here was Helen. How much does Helen's change by?
25.
Yeah, she was the 50 kilometers in the 2 hours. So she was changing at 25 kilometers per hour. Where did she start? At the 15. We see in our story she started 15 kilometers away. So if we wanted to know for sure where Ryan and Dan started, I could set those two where they would cross each other, pass each other. I could take their 2 equations and figure it out that way. If I wanted to know for sure where Helen and Maria passed each other, I could for sure mush that around and see who crosses where. We can also now see that Ryan is definitely going faster than Dan because Ryan's speed is 30 kilometers per hour and Dan's speed is 25 kilometers per hour. And we can see full on here that Dan and Helen will never meet each other on the road because they are parallel lines. They have that exact same slope. Okay, so we're just looking at all these interactions between the lines here and all the different ways we could try and solve this system to find all these pieces out. Graphing is all well and good, and it sometimes helps us see the pieces and see how they're interacting, but unless we are super duper ultra good at graphing, it's not the most reliable. I had to erase a few things a couple of times. And even then, my lines aren't super great because my Dan and Ryan look super parallel. But we know that Dan and Helen should be parallel. So graphing is not always our best option, but it's a good idea if we can't figure out what the heck is happening. Okay? So we are going to keep working with systems for the rest of this chapter. I'm going to put up here on the announcement page. I do believe we have a homework 3 this week, but I do not have it written down. But I do believe homework 3 is the page in between the 2 that we did today.
Do you know when the assignment closes?
They should not like close and lock until like May. You should be able to get into previous stuff.
Okay.
Like it'll say due, and you might not be able to get into it from the calendar because Canvas is super grumpy about late stuff in the calendar. But if you go through the module, you should be able to get into it anytime.
Okay, cool. Thank you.
Yep.